To help with review, I thought I'd do a few problems off of our summary notes. The first one I chose was the composition problem that actually winds up forming a parabola. F of x is defined as 2x squared plus 1, g of x is x plus 4. So find f of g of x and then graph it. So we just work inside out. So all this is saying is take the g of x function, which is x plus 4, and plug it in to the f of x function, and there's only one place it can get in there, and that's right there at that x. So the function that we're going to end up graphing is 2. Remember, this goes there, so x plus 4, and then it gets squared because of that, and then we add 1. So you could call it y equals, you could call it a new function, doesn't really matter what you call it, but we want to graph it. So we know it's a parabola just by the characteristics of its equation. We also know the vertex is at -4, +1. So what we really need to do now is maybe just find another point. So if we already know what happens when x is -4, y is +1, we know that simply from the equation. So let's go 1 to the right, and let's see what happens when x is -3. So -3 plus 4 is +1. +1 squared is still +1. 2 times 1 is 2, plus 1 is 3. So when x is -3, y is +3. And there's my next point. Now I also know that there's a reflective point across the axis of symmetry right here, which would be when x is -5. So instead of going back to that -4, instead of going 1 to the right, go 1 to the left, and then work it out, and you're still going to get +3. So that's all we need. Those are the lattice points we need to graph the equation, and there it is. Now, staying with quadratics, we're going to go the other way around. What if we know what the graph looks like? Write the equation to fit this graph. Well, let's start off with the parent function. Y equals a x minus h quantity squared plus k. Now, the vertex is the first important point we need to look at. The location of the vertex is 1, x equals 1, and then 1, 2, 3. So 1, 3. The location of the vertex is at 1, 3. Now that's going to help me write a lot of the equation. Y equals, we don't know the a value yet, but we do know the rest of the equation. In order for the x-coordinate of the vertex to be +1, the equation has to be x minus 1. And in order for the y-coordinate to be +3, this part of the equation has to be +3. So the way to find the a value is now use the other point, which is 1, 2, 3, 4, 1, 2, 4, -2. So y is going to substitute to become -2. We still don't know a. X is going to substitute to become 4. So -2 equals 4 minus 1 is 3. 3 squared is 9, so that would be 9a, and then plus 3. So now solve for a, subtract 3. Now divide both sides by 9. and you get a equals negative 5/9. And now you're ready to write the entire equation. Y equals negative 5/9 x minus 1 squared plus 3. And that's the equation for that parabola. Next up, we'll look at the exponential function. They're a little bit trickier because remember the key point in the parent function is not at 0, 0 like all the others. The key point is at 0, 1, and that'll come into play in a second. So let's look at this first function. Y equals 4 raised to the x minus 3 plus 1. Well, the equation itself tells us the shift for the key point. X minus 3 would mean go 3 units to the right. And then the plus 1 would mean go 1 unit up. So that's exactly what we're going to do. We're going to start where that key point is supposed to be, which is 0, 1. We're going to go 3 units to the right. And we're going to go 1 unit up. Now don't forget, there's something else that shifted 1 unit up also, and that's the asymptote. The asymptote is usually right here at y equals 0 on the x-axis, but it shifted 1 unit up. So here's the new asymptote at y equals 1. And really all we need to figure out what's really going on is maybe one more point on the graph. So we already know that this point is at 1, 2, 3, 1, 2. So let's see what the next point, to the right of it is. So I'm going to use a value of x equals 4. And just plug it in. 4 minus 3, so substitute x equals 4. 4 minus 3 is 1. 4 to the first power is still 4, and then add 1, and that's 5. So my next point is at 4, 5. And now I've got a good enough idea as to what this exponential growth graph is doing. Remember, it never touches the asymptote. So it comes in here, it makes a turn, it gets closer and closer and closer to that asymptote, but it never touches it. Okay, now we'll go backwards with the exponential growth. This time we see the graph, and we want to know what's the equation that makes that graph. Well, a couple of hints. Here's the asymptote down here at y equals negative 1. So we already know that the up-down shift was down 1. Now let's go back to where that key point usually is, which is 0, 1 right there. Well, if you look, it shifted 1, 2 units to the left. And here's where the key point normally is, 0, 1. It went 2 units to the left and then 1 unit down. So what that's going to do is that's going to help us develop a lot of the equation. It's going to be y equals, we don't know what the base is, so we're going to keep that as an a. But in order to go 2 units to the left, this part of the equation has to be x plus 2. And in order to go 1 unit down, this part of the equation has to be minus 1. So that takes care of that point. Now they gave us this point to help us with the rest of the equation. This point is 1, 1, 2, 3, 4, 5, 6, 7. This is 1, 7. So we plug in. The y becomes 7. We don't know what the a is. The x becomes 1. So 7 equals a to the third power minus 1. Add 1 to both sides. Now start solving for a. 8 equals a cubed. And you can take the cube root if you know how to take the cube root, or you can just figure out by mental math what number has to be cubed in order to get the number 8, and that number is 2. 2 to the third power is 8. So now you know everything about the equation, and you can write the equation. Y equals 2, because that's what my a value turned out to be, raised to the x plus 2 minus 1. Let's practice sketching a few functions with restricted domains. In this example right here, g of x is an absolute value function, so you know it's going to make a v, and since there's a negative 1 in front of the bars, it's actually going to be a downward v with a slope of negative 1, but the negative is what makes it down. So you could think of it, there's just going to be a slope of 1, but it's a downward v. Now here's the little kicker. It's not much, but here's the little kicker. This is only for the values of x that are less than or equal to positive 1. So what we're going to do is we're going to make a little boundary line. Now this is not an asymptote. It's just to help you make the graph. There's a boundary line at x equals 1. We only want the part of this graph that is to the left of this number, including 1. So let's evaluate it at 1. When x equals 1, y equals... So 1 minus 3 is negative 2. The absolute value of negative 2 is positive 2. But then the negative in front makes it negative again. So we're back to negative 2 again. And then plus 4 is positive 2. So when x equals 1, y equals positive 2. And I'm going to fill it in because I actually can use x equals 1. Now let's go to the actual graph itself. We know this is a downward v with a vertex at positive 3, positive 4. So if you thought of what the entire graph would do, the entire graph would go like that. But we don't want the entire graph. We only want the part of the graph that is to the left of this boundary. So all we have to worry about is the slope. Down 1 over 1, because remember the slope was negative 1, down 1 over 1. So it turns out this is what that restricted domain graph looks like. Now let's move on to the one right next to it on the summary sheet. H of x. Judging by the characteristics of this equation, it's simply a linear equation. And we want to know, where is this linear equation? Where is the line between the values of negative 3 and positive 5? Well, let's put our little boundaries in. One of the boundaries is negative 3. and the other one is positive 5. Now let's evaluate at those 2 points. This is h of x, so what would h of negative 3 be equal to? Negative 3 plus 1 is negative 2. 1/2 of negative 2 is negative 1. Negative 1 minus 2 is also negative 3. Now what about h of positive 5? 5 plus 1 is 6. 1/2 of 6 is 3. 3 minus 2 is 1. So here are our 2 points, basically the end points of the line segment. When x is negative 3, y is also negative 3. Now this one's an open circle because we really can't use the value of negative 3. Now when h is positive 5, or when x is positive 5, y is positive 1, and we can put it in a closed circle because we can use the actual value of 5. Now, those are my 2 endpoints according to the boundaries. Just join them. Now, if you want to check and make sure this is right, the slope better be right. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and so on. Okay, this takes us to what many students probably feel is the worst part of Unit 1, the toughest part of Unit 1, piecewise functions, graphing piecewise functions. Now, first thing you got to do is make sure you don't look at this thing in its entirety all at once. It can be overwhelming. So break it up into its sections. There's going to be a section of this graph that is linear. There's going to be a section that's quadratic, and there's going to be a section that is a constant. Now, the graph changes shapes at -2, +1, and +5. So I went ahead and I drew in the boundary lines really lightly at -2, +1, and +5. Now let's start evaluating at certain points that they're asking. What would be the answer when you plugged in -2 into the function, f of -2? Well, the first thing you have to figure out is which equation do I plug it into? Well, it's going to be this one because x is between -2, including -2, and 1. So this is the quadratic part. So -2 squared is +4, minus 3 is 1. So let's graph -2, +1, and let's fill in that dot because we know that that is where that point belongs. Now how about f of -4? F of -4, you would plug -4 into this part of the function, the linear part. -1/2 of -4 is +2 plus 1 is 3. So -4, 3. Now the last part, f of 3.7. You might be thinking, well, that's going to be ugly when I plug in 3.7 to see what the answer is, but it's really not because it belongs in the constant part of the graph. So when you plug in 3.7 into this graph, you get 2 out because it's a constant. So let's just kind of estimate where 3.7 would be. 1, 2, 3, almost to 4, but not quite. So 3.7, and then go up to 2, right there. Okay, now let's figure out all the little pieces. The easiest piece is the constant. Everywhere between x equals +1 and +5, the graph is at y equals 2. So I know there's a point here. I know there's the one that we figured out, and it stops at 5, but it doesn't actually include 5. So this part of the graph looks like that. Now, let's take the quadratic part. Let's take the middle part between here and here. By the equation, I know that it's a parabola, and I know the vertex of the parabola is 0, -3. Now, the leading coefficient of the x squared is just 1, so it would be over 1 up 1, but I can't put a filled in dot here because I already have a filled in dot there. So it's open. But what does the other side do? Over 1 up 1, over 1 up 3. So this part, the quadratic part of the equation, goes like that. Which leaves us just this, the linear part. Well, this is linear, and I already have 2 points. So I'm just going to plug in. I'm going to plug in -2 just to make sure. I don't even have to do that. Let's go to this point. The slope of this part is -1/2, down 1 over 2. So the linear part of this graph doesn't join those 2 points. It joins these 2. So that's what that piecewise function looks like. The furthest left part is a linear with a -1/2 slope. The middle part is a quadratic that has a vertex at 0, -3. And the last part of it right here is simply a constant. Now the last thing, let's do domain and range. So the values of x, it starts definitely at -infinity. Okay. Now, does it go continuously to the end? Yes, it does, because even though that's an open, it gets filled right there. And even though that's an open, it gets filled right there. So it goes all the way and it ends at +5. We don't use +5, so we leave it open. Now the range. Think low to high. The lowest point is -3, and we do use -3. Does it go continuously all the way up? Nope. It stops right there at +1. And then it kind of jumps to +2. So we do that, and we pick it up at +2. And then it goes up on this side forever and ever and ever to infinity.